from CMD. He's got over 15 years of experience in cybersecurity, and I'll let him introduce himself.
All right. Thank you so much. You guys hear me okay? Great. Hey, thanks for showing up. Thanks for being here today. I'm really excited. This is my first BSides talk, so go easy on me. But I'm actually from Connecticut. I grew up in Trumbull, so I was really excited to come down today and see you guys, and gals. So I'm going to be talking about privileged access management on Linux, and a little bit of background. Well, before I get into anything, I saw this on, any of you guys see this on Reddit just a few days ago? I saw this on Reddit just a few days ago, which I thought was very coincidental given I'm giving a talk about this right now. I'll give you a second to read it. All right. The chuckles tell me you've read it. I wanted to just put this up there because when I think about privileged access or access in general, this is just a reminder that it's a very human problem too, right? There's, if you think about it, what we're doing is we're taking a computer and we're telling a machine, hey, you have to authenticate a person. And here's some rules that tell you how you're going to do that. And once you do, I'm trusting you, the machine, to make that decision. And then from then on, you let them do whatever they need to do. And that is fine if you have a lot of right technology, but because there's a human on the other end, because there's humans all throughout that, humans could take advantage of that. And that's social engineering. That's hitting somebody with a wrench until you get their password out of them. All these examples are ways that people get around access problems, that attackers get around access problems. So I just thought this was an interesting one. It kind of reminds me about the human angle of security, which is really, really important. So that's kind of what I'm going to talk about today is privileged access management, particularly as it applies to Linux environments. And I talk about high velocity, high scale, data centers and clouds, these types of environments that have really exploded in the last few years. We'll talk about what PAM, which has been around for decades, but what it needs to do today to operate well in those environments, how data and analytics can actually solve some of the challenges that we have with access in those environments. And then I work for a company, CMD. We're getting ready to release a free product, so I'll just give a little plug for that because it's free. So yeah, I've been in cybersecurity for 15 years, 17 years actually. I'm not an analyst. I've never worked directly, stopping threats. What I do is I work with companies who are developing innovative security technologies. I work at CMD now. Previously, I was at Carbon Black. I was at Bit9 in the early days. I worked at RSA back in 2004 on the security ID token. So I've kind of been in this space for a really long time. And I've done a bunch of consulting for a lot of other companies too. The last few years, I've really spent a lot of time in threat research and working with the data that we're seeing in actual incident response scenarios, the data that we can collect in clouds of all the activity that's going around, that's going on, that's leading to breaches and things like that, and working with these teams to understand the story, understand what was happening, and help communicate that out. And what was really interesting through that experience, because I actually have a technical background. I got my computer science degree way back when, so I can get a little deep in the weeds there. And what I think is so interesting about that whole space is kind of watching how attacker behavior evolves. And what we really started to see over the last few years was all this technology that we're building to keep people out of where the goods are. But the truth is they get into those systems, and those systems are primarily Linux these days. There's so much information that the attackers are after that is sitting in the cloud and sitting in data centers. So I just thought this was a really interesting space, right? And as much activity is happening in cybersecurity, there was this lack of solutions for how do you really secure Linux. And then a few months ago, I got introduced to this company, CMD, and they said, we're going to solve the Linux security problem. And this is my first Tom Cruise movie reference of the slideshow. So I just totally broke down. I said, yeah, you got me. That's the space that I just know there's a lot of opportunity for security. So I've been at the company for 3 months now. So I want to kind of back up and talk a little bit about the problem with Linux security and just kind of do some framing here. And one of the biggest problems with Linux security is so much effort has gone into securing the network and securing Windows, and it's not really hard to understand why that is. You know, a few years ago, Linux was so much smaller than it is today. And so for decades, we've had to secure networks and we've had to secure Windows. And many companies, if they had Linux, it was a few boxes that people needed to log into sometimes. And you could treat those boxes very much in the same way you treated any other kind of Windows box. So you see a lot of vendor solutions that were built for Windows and the security problems of a Windows network, and they port them over to Linux, and those solutions don't necessarily fit the problem that's over there. And this is one of the things that I've experienced for years working in this industry is customers who really are pushing the boundaries of Linux and the cloud and these data centers and these high scale DevOps environments. Customers who are really pushing those boundaries are just frustrated with the state of the products that are out there. Like many of you guys, you probably know how to secure Linux. Like IT security, Linux is it's a securable platform, right? There's a lot of information. It's open source. You can get in deep. There's a lot of capabilities in there. The problem is, how do you roll that out at scale in a high velocity, very fast changing environment? Linux is exploding. It's, 2.3 billion public facing servers. I think there's on the order of 2 trillion servers that are actually running like inside all these clouds. It's just enormous, and it's going to grow and grow and grow. You look at IoT security, all the IoT devices are built on Linux pretty much. Linux is just exploding. The top websites, all the top million servers, and the data, of course, is moving into these systems as well, and that's what the attackers are after. But the solutions for securing these environments, they don't really exist. When we look at, this is a chart that Gartner produces, and this is workload protection, which is, maybe a more advanced version of server security. But they used to draw a very similar chart with slightly different terms that was just server security. So you can really look at this chart and say, yeah, these are the best practices for securing servers in this chart. And I'll just draw your attention to the things that are at the top, which are less critical. Things like anti-malware and even EDR is up there. But these are less critical in these server environments, but it's actually where a lot of the products and a lot of the mature companies have built products in these spaces. The stuff at the bottom is much more in the realm of practice. Best practices, good hygiene. All the way at the foundation, we have things like hardening, configuration, vulnerability management. How do you make sure there's no arbitrary code running? How do you make sure privileged access is locked down and changes are locked down and you're capturing logs? And all that, if you are building the system and you know this, you can build it. There's solutions for that. There's ways of building cloud systems with good hygiene. But think about how fast the cloud is exploding and how developers are cranking up machines quickly, cranking up environments. They're deploying apps quickly. They're putting something in beta. And guess what? It works, and customers are happy, and their company puts pressure on them, and suddenly that gets rolled out to production. So the problem isn't really how do I secure Linux? It's how do I make sure that all the people who are building out these massive cloud systems and these applications, how do we know that they're following the best practices that are dictated by something like this? That's, after a few months here and all the years I've had in this industry, this seems to be a huge, huge problem in Linux, in these large environments, is how do I know that the policies, as a security person, how do I know those policies are actually being followed? It's really hard to figure that out. So what do you have to do? You kind of have to assume that you've been breached. And even if this is a mental exercise, right? Even if this is, all right, I don't know that I can completely block everybody from getting in. But a lot of times if somebody has a password, if they were able to get a rogue credential somewhere, if they were able to steal something off the web or take advantage of a vulnerability on some system that hadn't been updated and get in, they might stay there for, a couple hundred days before something actually happens. And in that time, they're doing something. So you have to start to think not how do I keep them out or how do I know when they're just about to exfiltrate data, But what are they doing in those couple hundred days? Right? Because that's your best chance of finding them if you can find them doing all the things that they do to get from their initial access point all the way down to the data that they're after. And the types of things that they do are reconnaissance. They look around at the different machines. They see what the environment looks like. They probe. They look for other accounts that they can hijack. So they can move from box to box from, a low-level account to a higher-level account. They look for software that's out of date or vulnerable where they can trigger some kind of an exploit and trigger higher privileges. They move from machine to machine. All these things are the types of activities that happen after the breach, but before the incident, right? Problem is, these are really hard to detect. We just really don't have visibility. If you've got, thousands of servers running in a typical cloud formation, and you've got to track all that, and all those logs are coming in, it's really hard to find the one instance of somebody probing from one system to another system. Now, as a human, you can see it, right? Every day, the only thing that happens on most of these servers is they get rebooted. And one day, somebody runs a couple extra commands. And that should be super suspicious. And as people, we can look at this and we could say, man, I really want to know what was happening on October 27th. Like, give me all the information around that. But the types of solutions that are out there for gathering and correlating all this data can be really hard to spot this. This is a needle in a haystack, but it's a pretty compelling needle if you can find it. It's really hard to get it. So it makes you think that something's really wrong with the way we do Linux security. We're kind of approaching it a little backwards. We don't have the right solutions. Instead of focusing on hygiene, the market is focusing on these higher level solutions. What we really need is, how do you give an IT security professional the tools, the visibility, the control that they need in these vastly changing large Linux environments, right? And so that's kind of where we started. So how do you solve this? So I want to kind of talk a little bit about starting from scratch, right? And I'm going to go back to this diagram and say, all these security solutions that you have on top of this, if you don't have good hygiene across your environment, it's really hard to implement a good security solution. And so let's start with that foundation of hygiene. How do you harden your configuration, your vulnerabilities? How do you make sure that you're doing the right things operationally? And I think this is really interesting when you actually look at these individual foundational elements, right? So there's 4 of them. I'm going to start with log management because I think most companies do pretty good log management. There's a lot of products out there. You can suck all logs into a SIM or into some other kind of log management tool. You get all that stuff out there. Now, the quality of your logs may be a different story, but at least you can do a fair amount of log management. But some of these other things are actually really hard in these environments. So look at no arbitrary code, no email or web client. Probably you're not running an email browser or a web browser in a Linux cloud that you're spinning up. But how do you know that you don't have arbitrary code running? Like, you'd like to believe that there's no arbitrary code running, but hey, if somebody's got root access and you don't know that they went in and downloaded some binary just to try it out, somebody's responding to an incident and they needed a tool and it wasn't tracked or recorded, right? But they needed it right then. There's actually a lot of instances where arbitrary code does get run in these environments. And it ties back to, how did you manage the privilege that allowed somebody to do that in the first place? And change management, similar story. How do I know that the changes that are happening are the changes that are supposed to happen? When I look at a high velocity DevOps environment, a CI/CD environment, I've got code dropping into production multiple times a day. You really have to trust that all the right steps are happening, right? It would be great if DevSecOps was real, if we developed code and tested it for security unit by unit and rolled it out into production, and that all worked great. That would be wonderful. But that's not really how most organizations operate at this point. So you do these changes, and the volume of change is significant. And how do you really know the right changes are happening? If you don't have good privilege access management, It's actually hard to really even tell that. So we look across these, and I think in Linux, a lot of the problems here come down to the way privilege access works in Linux, right? If you solve that, you can bubble that up and improve hygiene all across the board here at a foundational level. And privilege access on Linux is a security hole big enough to drive a truck through. And what do I mean by that? Well, once you get access, you can do anything that account lets you do. You can do anything. On a Windows environment, you've got GPOs, right? You can, as a security administrator, you can set policy that even a Windows administrator has to at least jump through hoops to get around. And those hoops you can track. But most Windows administrators are not bad people. They will hit one of those guardrails and realize, oh, I guess I'm not supposed to change that. I better find another way, instead of actually trying to actively subvert the policy. None of that exists in Linux. If you get root access, you can do anything. You're God. And there's no protection. There's no guardrails from threats, from errors, from mistakes. Somebody could log into a production environment thinking it was a test environment, make a change, install a tool to help them debug a problem, leave it there by accident. That tool has a vulnerability in it. There's all sorts of errors that can happen along the way, and you don't have visibility and you don't have guardrails to keep that from happening. I've used this picture. I've used this scene. You guys know what this is from? Does anybody not know what this is from? Maybe I'm just like super old, but like this is like a classic, scene. This is one of the classics, Mission Impossible. I just was reading about this. Tom Cruise did all his own stunts in this too. Like the one where he's lying like an inch from the floor. That was all real and all him. But I'll set it up, right? So this scene, they're trying to get, the list of agents that's stored on this computer that's in this secure facility, in the super secure room inside this even more super secure facility. And there's all this technology that exists if he were to walk directly into the room, scanning and biometrics and all this other stuff that he would immediately trigger and he wouldn't be able to get in. So what they decide to do is wait until the room is out of operation, right? Nobody's in there. Nobody's logged in, and they sneak in through the ceiling. And the thing is, the room is, making sure nobody can sneak in because the floor is touch sensitive. If he steps on the floor, if there's like a drop of sweat lands on the floor, it's going to trigger the alarm. I think there's temperature controls in the room, so they have to like keep the temperature at the right thing. There's noise, there's microphones. So if he's too loud, it's going to set off the trigger, right? So they go through all these gymnastics, and then he's, kind of flying there right above the keyboard. And he goes to the keyboard and he types in the password that they stole. And he puts a disk in the machine. And he downloads this super secure list that all this technology was built to protect, to make sure nobody downloaded it. Now, I wonder why there's a floppy drive on this machine in the first place, right? That seems a little ridiculous. But if you think about it, it's a really good parallel to the way like development and operational security kind of work, right? A developer built this machine. A developer built the system that holds the data. They weren't really thinking about security at the time. If they were, they might have put in something on that machine to make sure that, you can't log in if the door is closed and we're in the off mode in the room, right? You might say, every time somebody logs in, they're walking on the floor and I can detect that. And this time somebody's logging in and there's nothing on the floor. Maybe that's risky. Maybe there's something wrong there, right? There's all this data that the security people had to build a really large, sophisticated fence around this thing that the developer built, to make sure that nobody could, penetrate it to the point where the weak security is exposed. Right? There's so many things that if you actually tied in what's happening on the system to what's happening in the room, there's so much data there that would make this whole thing just a ridiculous concept. Right? And I think I've used this, this scene, I've used it actually multiple times in talking about multiple different security issues. I still think it's a great scene and a fantastic movie. But it really illustrates, I think, what happens when you have development and security and they're kind of separate. and they're not sharing data, and they're not sharing information, and they're not building secure systems. And it would be great if those groups worked together from the beginning, but a lot of times it's just not reality, right? Even Linus Torvalds, and this is only a few weeks ago, finally admitted that this hole in root security is something that should be addressed. That there should be a way to lock down a kernel in Linux, even if somebody's logged in as root, right? He pushed back on this for a long time. I don't really know why, but he pushed back on this for a long time. A lot of the flavors of Linux have actually put this technology in, so it was out there. But there was a resistance, all the way up to Linus himself for getting rid of this idea that a root user is essentially God. And I think times have changed enough now where, yeah, you know what? We need to have some security controls even for a root user. But that's not how most of the systems that are in operation now are working. So we have this hole, and it's something that we have to deal with. Now, how do you deal with access today? Well, I kind of mentioned earlier, a lot of these access control solutions were built for Windows and then ported over to Linux. And so, I mean, without naming like who these tools are, I just wanted to show like some of the techniques that you see for how you deal with privileged access out there. This one, it's very much like a Windows administrator's view, right? Okay, I've got not 1,000 servers that I'm trying to manage, or a bunch of, ephemeral servers, right? Servers that are coming in and dropping out, and containers and all that. But I have a list of servers that I can browse through and identify, and I'm going to want to log into one of them and not supply a password. I'm going to grab it out of a vault so it's one time and it can be tracked to me. It's built through this proprietary tool. So if you are in DevOps and need access to that server, it means you've got to go out of your workflow and go into some other browser and log into some other system and grab the password and bring it back. That's not how DevOps likes to work. That's not how people who build in Linux like to work. And you don't have any control. Once they get in with root access, they can do whatever they want to do. This is another one that's a little newer, a little more recent. It gets rid of the password vault. It's got some other benefits over some of the older PAM stuff, but it still does not strike you as, yeah, this is the way Linux is supposed to work, right? People who work in Linux, they love Linux. Like it's a lifestyle almost. It's a way of working, and it's not this. Totally different world when you go there. So where are we? So we've talked about kind of the problem with access on Linux, and we've talked about the state of the tools that exist to protect that access. And so now we're at a point, you know what? What if we took a totally different approach? What if we started from scratch and said, if we were going to build a privileged access system for today's Linux, with DevOps, with cloud, with massive data centers, with high velocity code changes, with developers or operators who need root access to solve problems, because problems happen all the time, with containers. If we were going to start there, what would it look like? So I think there are 4 things that you need in this kind of environment. If you're really going to have solid visibility and control over who's logging in and what they can do. So the first one is 100% identity-based tracking. Everything that happens should be tied to an individual that you can recognize, right? Now in Linux, you have shared accounts. It's so easy to take an account, take a password, and pass it over to somebody else. Like that, it would be great if you could disambiguate that. And that, Brian's password, or Brian used the shared account on this instance, but Sam used the shared account on that instance. So I think we need this. We need 100% identity-based tracking. The second thing we need to do is we need access control, not at the session level, but at the command level. It's fine if you want to browse a directory. It's not fine if you want to dump a customer database. We should be able to get granular enough to create those rules. Then we need detection and remediation of access gaps. So what that means is if somebody is doing something that they're not supposed to, man, send me an alert. Let me know. Tell me, this person did something that they're not supposed to, and there's an opportunity to fix it, right? And we don't fix it by putting anti-malware signatures in the way you do on Windows. You fix it by going back and changing the configuration of Linux or changing the configuration of the container. That's what we do in the Linux world. So you need to be able to detect those gaps and you need to be able to remediate them. And then lastly, it's got to be DevOps friendly. If your developers and your operators, if they have to jump into another tool, if it doesn't fit with their tools and their workflow, they won't use it. And anybody with a credit card can pull their credit card out and open up their own account and start doing stuff and integrate it in. You want to make it as easy as possible for the rest of your developer and operational organization to actually use it. And that means take the responsibility out of their hands, right? Put it into the IT security hands. And these are different than what's available today. So I'll call it old PAM. I wanted to find a picture of PAM from The Office, like through one of those age filters and put it on here, but I couldn't find that. So I'll just settle for the name old PAM. So old PAM identities are only tracked with they're only tracked if you go through these proprietary access methods. So you're used to writing sudo. Well, now you have to write something else do, right? You're used to just logging into a machine. Now you have to go get a credential from somewhere else and you have to drop in. So only if you use these proprietary controls. You only have session level access control. Are they allowed to log in or are they not allowed to log in? And there's no detection or remediation, and they're really built for the Windows case. So we need something kind of different, right? And it's got different requirements. Now, to do that, we started to think, all right, well, how do you do that? Like, what would you need to do if you're a security professional and you want to put those requirements in place? You need a lot of data. And that's what I'm going to talk through next is like, what kind of data do you actually have access to? And how would you use it to address these requirements, to fulfill these? And it's kind of like what we're doing is saying, all the stuff in the Tom Cruise room, in the white room, we're actually going to plug it into that login console on the computer. And in fact, onto every command that he issues, right into the operating system. So everything knows the state of the room, where he's hanging and dangling right there. So you get that data, you put it centrally, you can build monitoring and detection on top of it. You can use it to define policies that are really granular, and you can use it to enforce, control what's actually happening. And so that's kind of the model here. Totally different way from the way access management is done today. All right, so now what I want to do is walk through what some of that data looks like and some of the work that we've done with customers. And if you were going to be doing some of this stuff, like what kind of data would you need to suck in, and how would you want to evaluate that, and what kind of stuff would you need to do to make these decisions as you go? And what you find is that, like, this is hard. There's a lot of data available. You can just imagine the volume of data. We've collected like 40 billion data points at this point, command line arguments that we're using with all this context. And we're starting to see some really interesting patterns, and we see them even with a single site. But it's a very different way of solving this problem. So what kind of data is available to us, right? There's actually a lot of data that comes with the command line that you can capture. So you know when the command was executed. You know who did it, whoever was logged in, maybe not the specific identity, but whoever that login user was. You have all the data that's on the command line itself. You know how that command line was issued. Is it an interactive session, or was it done through a shell script, and on and on? It's actually a lot of information that's sitting in the room, right? There's a lot of information that if that computer was connected to the rest of the room, can make a much smarter decision. So first we have to collect all this. We have to pull it together. And then you got data science. Data science in this area is actually pretty hard, just like it is in security in general. And I think one of the biggest things that makes it hard, it's actually the second point on here, is the fact that security data is not stationary. So I can set up a machine learning algorithm to identify a bowl as opposed to a fork or a spoon, because bowls don't change. I mean, they may change a little bit, but basically bowls have certain characteristics that don't change. Forks and spoons, same story. But security, there's a human on the other end. Security tactics change all the time. Attacker tactics change all the time. They try new things. So you're not working with a stable data set. You're working with a data set that's actually always evolving. That means you have to constantly be retraining your algorithms on this data. So that makes it hard. The assumptions that you make about that data, to the first point, make it hard too. Those assumptions can have big consequences one way or another. It's actually hard to get accurate training data. So nobody's sitting there saying, here's all the commands that were run and who ran them. Like, you have to get a lot of good training data in that's reliable in order to create these algorithms. So it's hard to even accumulate that much data. The data may not be rich enough. You may not know the features of the data. You have to be really accurate in how you classify the data. All this stuff makes data science hard in this realm. But as we start to look at it and we start to see it, because there's so much of it happening, we got a large pool, we can actually start to build some pretty decent algorithms out of it. And then we can start to do really interesting things. So there's a bunch of stuff that we could do with this information. If you know every command line and all the context around every command line, you can start to model user behavior. And that's the one I'm going to dive into. So I have I'll kind of walk you through what that actually looks like in actually real terms. But you can detect shared credentials. You can detect intruders. You can prevent sensitive information hacking. There's a lot of stuff that you can do with this information at that granular level once you have it. But let's dive into that user behavior modeling scenario. So this data here, these next few slides, are actually from a real site where we collected data and we ran these algorithms and we actually discovered some interesting things going on that the site didn't know about. So first thing, like, obviously we've changed the names. It's not really Bob and Alice and all them. We just put those names in. So what we're looking at here are a set of 6 users that had access to this environment. 3 of them aren't active. 3 of them are active today. And the height here in the purple or the gray, that shows kind of their average number of sessions per day. The green is how many sessions those users have executed just on this day, today. Right? So we're going to look at Bob. Bob, this is his 3rd session of the day, and typically he executes, I don't know, like 8 or something like that, whatever that number is. But you can kind of see just that average across all these. Obviously, if somebody one day logged in 1,000 times, that would be a flag. We can look at these 3 sessions that Bob executed, and we can start to look at the commands. So what was he doing? It'd be nice to know what he's doing. And it turns out 2 of these sessions looked similar to each other. He executed a lot of root commands, but one session looked different, and he was executing a lot of file commands. Now, knowing Bob's job as an administrator, he's really there to make sure the machines are healthy. He's not there to move files around, so maybe there's something interesting there. Now, if you're just looking at those command levels, no analysis is going to just trigger and say, oh, somebody catted a file. That's got to be bad. But what we're trying to do is build a picture here across all this information. And so that stands out. We can pull in some more information. Where did he log into? Where did he log in from? And again, we see a discrepancy between the 1st and 3rd session and the 2nd session. So in the 1st and 3rd session, he was logging in from a private IP address. In the 2nd session, he was logging in from a public IP address. And we rewind the tape and look historically, and it turns out, hey, there's actually a series of sessions over the last, week or 2 weeks or whatever this time frame was, where he's logged in from public IPs. Now, maybe the system doesn't have the right access control. There's a configuration somewhere. Maybe nobody ever thought to make sure that you can only access this environment from a private IP. Maybe that control was never put in place. But it's interesting to see it. So we dive a little deeper. We take a look at the next thing, which is, all right, so we know where he came from. Now, what systems is he accessing internally? And remember, Bob's job is to make sure that the systems are healthy. And so you could see 2 of these sessions, actually in all these sessions, he accessed these front-end systems or a particular front-end system. That's fine. That's what he's supposed to do. But one of these sessions, he's accessing a system that he doesn't normally access. It's a billing system. So there's a red flag. We can look at time. When did he log in? He's got a very specific pattern of time. He logs in between, 2:30 p.m. and call it 9 p.m., sometimes 10 or 11. But then there's a few times in the wee hours of the morning that he's logging in. And we see some of those as well. And if you're reading logs, if you're looking at any one of these data points, nothing might flag to you. But at this point, you've put enough together to say, you know what, there's a lot of fishy things that are here. And what was required was taking all that data, correlating it together, looking at those patterns, and calling them out. Right? So what do we know from this? Well, the data, I showed you like one day, a couple sessions. But as it turns out, as we study this data, a user's patterns across all those data points create almost like a fingerprint for that user. So, the way one person logs in and interacts and the commands that they run isn't going to look like a second person or a third person. What that means is if you do see the first person looking like the second person or the third person, it's probably the same person using multiple accounts. That makes sense? You can use this as a fingerprint to say, look, we think Bob's been doing some shady things. And we could take his fingerprint, though, and we see Joe has the same fingerprint. So what does that tell you? Well, either Bob's a bad guy and he's grabbed Joe's credentials, or somebody has figured out how to access both Bob and Joe's credentials. Right? So there's a problem. And we can see a little sliver in Carol's account too. That, oh no, now they've found out who Carol is, and they're attempting to figure out what she's got access to. So we see some of those same patterns. Right? And this fingerprinting method, which if you look at any one of these data points individually, it's not that telling. It's not like enough to spin up a whole response on. But when you look at them across all these data points, and we touched on a few, but there's a lot more data points that you have access to with this, you can see these patterns. You can start to build some trust. So what do you do about this? Well, you see this, and immediately you might say, all right, everybody, go reset your password. And then it would be interesting to see what happens to Bob. Does his behavior stay the same, or does it go back to a green state? Right? Now you know if Bob's a bad guy or if somebody else just accessed his account. You might start some active monitoring, trigger alerts for some of these fingerprints coming up. And maybe hey, this is a really good time to get some two-factor authentication in because we see somebody's in this environment. They're interested in being in this environment. We better make sure that the right people are authenticating themselves before they get access. So we did this, this was a real site where we did this data analysis. And the conclusion of this was we actually found out that there was a rogue employee, a contractor in, I think, an Indian, based in India, in an India-based outsourced portion of this company that was doing some bad things. I don't really know the details. They wouldn't share what the details, not surprisingly, they wouldn't share exactly what he was doing, but they got rid of the employee. And they found something that they wouldn't have found before. And you can see it right there in the data. So really interesting example of how this information can identify somebody who's doing something bad, in a real world scenario. All right. So we kind of go through that. So what does all that mean going back to privileged access management? Well, that foundation of data and the things you can do with it, the analysis you can do on it, the controls you can build around it, actually lets you address all these requirements. So first of all, you can make sure that everything gets tracked back to an individual person. You do that with a combination of a two-factor authentication every time somebody logs in. But now when they do, you can actually confirm that any action that's happening, you know who did it. So you can do that. You can put access control around those individual commands, right? You can intercept a command and block it from happening if it's bad. If we have a customer who's making sure that if somebody logs in, it's all right. Somebody logs into production during normal working hours, that's fine. if they log into production outside of normal working hours, they need to have two-factor authentication, right? So you can start to put these really interesting rules in to fit your business logic. You can alert. Like everything that we just walked through was detecting something that was wrong and being able to alert on it and then being able to identify the problem and go back and fix it. And this technique is DevOps friendly. You don't have to take your developers outside of their comfort zone. They can continue to use the tools that they want to use, which means it's easy for them. So it meets those requirements, which is good. That's what we were after. And ultimately it leads to a few good benefits that kind of really matter in the way IT security does their job. You get better change tracking. So there's no identity gaps.
Hello folks, I'm Geek here. Unfortunately we had an audio glitch, so we have no more audio for the rest of this presentation. Sorry for the inconvenience.